it up, move it down, whatever works is cool with me. Which piece of that do you not have to worry about at first? There's a lot of exponents up there. I like that. It's like, who is it? That guy. Which guy? Yeah, that exponent I don't have to worry about yet. Right? I can do him last. Why do I know I can do that last? Because order of operations says do the inside first. Right? Don't worry about that piece yet. What can I do on the inside?
You're going to want to bring the 4, the x to the 4.
Just telling me to steal a second. It was like basically sound like that. So, what doesn't want to move inside? He's fine where he is, right?
Yeah.
So those 4 x's want to go up, and these basically want to change places, right? Because the one wants to go down, the other one wants to go up. You guys see that? Negative powers make that thing move to the other side of the division bar. Yes, sir?
Now, if it goes down, should it still be -7? Or
No. Otherwise, it would never stop moving. Right? If it's negative down here, it will be positive up there. So I've heard it said, even though this sounds very kindergartenish, it's negative down. Don't like it down there. It's going to like it up top. So it's going to become positive when it goes up. It's sort of like the same mistake, and I know we haven't done roots officially, but you guys know what the square root of 4 is? But I often have students that tell me it's that. It's like, if that square root symbol never goes away, when will I stop? I'm not done yet, shit. But it's 2. So the negative power is not negative anymore once it's done its job. Otherwise, it would just keep going up and down, up and down, up and down forever, and I can't finish the problem out. Right? So when those 4 x's come up, those 2 stay like you told me. Those 4 come up there. Those 11 y's go up. And those 7 y's go down. And now I can just attack that directly. How many x's do I have? 6. So 6. How many y's do I have left? 4. Where? On the top, because that's where more of them are, right? If it would have been 7 there and 11 there, 4 would have been left on the bottom, because that's where more of them are. Does that make sense?
So we go wherever more of them are?
Of course. Because I would cancel 7 out. Where would there still be some left? Up here, because that's where more of them were, right? Does that make sense? So you can imagine a row of 11 y's and a row of 7. There's still 4 up there. If there would have been 11 on the bottom, there would have still been 4 on the bottom, right? Okay. Does this all sound familiar? This is what we did a week ago now. No, but still. And so we get y4. Nothing on the bottom really, just a 1 really, so I don't really need that. Now I can do what that outside power says. And what's he say to do?
Flip it again.
It says flip this and then square it. So you look at a negative power on the outside, like 2 commands. It says flip it because it's a negative, and then I still have to square it. So do it one at a time. So flip it first. And I still have to, I haven't squared it yet, right? It's not negative anymore because it did its job. It's gone now. And that equals what? 1 squared is 1. I like it. Careful. 2 groups of 6 x's is 12. Y to the 8th, yeah. You multiply when you raise a power to a power.
Now why don't you do an equation like that, but instead of x's, there's numbers in front of the
Works the same way. But that's where people make huge mistakes, is when they have like this here. I know it. Those evil puzzle problems. Put her away.
That's one last question.
This kind of problem messes people up. But the 3, I mean, now look at this. If it was x4 over x7, how many x's are left? Where? All right. Right? Let me stop right there and make sure. Is everybody cool with that? If you want to, there is nothing wrong with using the property. What do you do when you divide? What do you do with the exponents?
Subtract.
So another way to do the same problem is 4 minus 7 is
Negative 3.
-3, but what's the negative power mean? Flip. So that's why I personally, you don't have to do this, but personally I just like never bring negatives into it if I don't have to. I know there's going to be 3 left down here because there are more down there. 4 of them die, 3 of them are left. Right? So what's the difference over there? How many 3s would be left? How many 3s do I have on the top? 4 of them. How many 3s do I have on the bottom? So how many 3s are going to be left?
3.
Where?
On the bottom.
Okay, it's the same stupid thing, right? Here is the symbol x. Did that symbol x change at all? Here's the symbol 3. Why should it change? It's got to act the same way because the variable is a number I don't know yet. They got to act the same way. So this will still, the biggest mistake I see is people cancel those out somehow. There's only 4 3s on the top. How can they cancel out all 7 3s on the bottom? That's impossible. You can't do that, right? So you still have 3 3s on the bottom. What's 3 cubed? 27.
Now that won't be 27 though, right? It would be 1 over 27, right?
1 over 27,
But
exactly.
you can't write it as 27 though, right?
Because that's a different number.
Okay.
Yeah. 1 over 27 is not the same as 27. So it won't be the right answer.
So
So
if
you
it's
just have it
27
on
over
the
1.
Then that's the same as 27, yeah.
Okay, I see.
Well, 1 over 27 is a number much smaller than 1.
Yeah, okay.
Yeah. How are we doing so far? Another big place, I think even easier place to mess this up would be something like, let's say 7 squared times 7 cubed. The wrong answer I very often get is this.
Why don't you just do...
Now what I normally write on a piece of paper that's when it gives me this, I say, I don't see 5 49s over there. I see 2 7s and 3 7s. How the hell did you get 5 49s? And I want you, if you could do that, I want you handling my money. Here's $2 and $3 and you give me back $500. That's awesome, right? The Jesus of money. Oh, wow. Sorry. But what really happens here? How many 7s? I've got 2 7s, 3 7s. Overall, I've got 5 7s, right? 7 to the 5th power. The property doesn't care what symbol is here. That symbol happens to mean 7. But exponents just say, okay, I got something squared, something cubed. What's the property say? Add exponent.
But since you're timesing or multiplying, you don't multiply the exponents only into parentheses.
Here's the big key. I want you to realize this. Exponents are not truly numbers. They tell me how many of this thing I have to multiply eventually, right? So if I have this much work to do, I got to multiply 2 7s. And somebody comes over, here's 3 more 7s for you to multiply. Well, then I got to multiply 5 7s eventually, right? I'm not multiplying anything yet. In fact, that's why exponents exist. They're like, I haven't multiplied anything yet. I just have 2 7s that I have to multiply. So if I multiply 3 more 7s, how many 7s do I have to multiply now? 5.
So what if it was plus?
So if you have the same thing, just with a plus sign in the middle, are those like terms?
Yes.
Are they?
No.
I have 1 7 squared, and I have 1 7 cubed. Can I put those together?
So it's
No.
it's not. You can do it.
You can do one thing. What is 7 squared?
49.
49. And what's 7 cubed?
What if it's like 4 12 plus 4 5?
Same idea. You cannot do it.
In the book it says does not apply.
Good, I love it. Because they're asking, does this property apply? No. Because what's the only time you can add exponents? When you multiply things with exponents.
So if we're saying we just cancel out exponents and we do that, just make them go.
Yeah, if they're not like terms, then you're forced to actually work it out. They're numbers. I can actually work it out. 7 squared is 49. 7 cubed is 340. And then I can add them. Because now I got like 49 ones plus 343 ones. That's like terms, right? I can put those together.
So you have to
So that's what we're
figure it
supposed to do with
out.
addition.
How we doing? All right. On one level, I don't want you guys to
So if I said,
make it seem so like so much to remember that you start to get a little frustrated. These are all good questions, but I don't want you to feel like you got to keep all this stuff in your head at once. Adding, subtracting, you always need like terms. I don't care what the hell you're doing. We know that. In fact, that's why I need LCDs when I have fractions. It's the same idea, like terms. When I multiply, I don't need like terms. Now, when I multiply things like this, I need like bases, don't I? So I can collect them together. Yeah.
How about the base number, like 7, 7? What about the different, like 7 and 8?
Then you can't do it. Right? You can't collect those together.
But those you can, like you said, you just did it, you added them. So 49 plus 3,
Now you can add them together.
That's something
Yeah.
that's solved it, that's the way you're gonna have to do it.
That's the only way you can do it.
Exactly.
I like it. In fact, we saw like one like that last time with negative powers, and we just made it fractions and put them together. Okay.
That's like turn around 7/3 plus 7/3.
I love it. And that one, all right. And again, these are great questions. I just don't want you to get confused with what's going on. 7/3 plus 7/3. Now this is a little bit freaky. A little bit freaky. They're like terms, right?
Yeah.
How many whats do I have up there?
30.
No.
No, you would just have 7.
I have 2 7/3. That's what I have. Why can't I make that 14?
Because
What do I have 3 of up here? I have 3 7s and 3 7s, right? I don't have 3 14s all of a sudden. I can't do that.
That's what I guess.
So you really just simplify it. I mean, it's the same thing.
Yeah,
Same idea. Anytime I have something plus itself, that's twice that thing. We know that. Isn't that just an application of that? This thing plus itself is 2 of itself. What's order operation say? Can I multiply before I exponent? That's why I can't get 14. You can't multiply before you raise to a power, right? It's power before, and the multiplier is a little bit down, isn't it?
Yeah, so you can actually go off and solve that.
Sure. This, like we just saw over here, is 343, and that's 686.
Oh, okay. That's just the way I gotta start thinking about it. Instead of there's 14, there's no 3 or 14. It's gotta think of
Yeah, I don't have 3 14s up there. I have 2 7 cubes.
That's the way I gotta start thinking.
Exactly. And this is getting a little bit further than we have to worry about at this immediate time. But these are good questions. But I don't want you to feel like, holy shit, I remember all this stuff. But I tried desperately to teach you things that are true no matter what you're looking at. Like terms when you're adding and subtracting is true no matter what you're looking at. Right? Order operation is true no matter what you're looking at. Yeah.
Can you explain what it is?
Which one?
Like I was 65 or
5 1. Oh yeah. All right, let me.
I'm pretty sure I know how to do it. I just have a brain fart.
What's I spelled something. What's this?
Five, six, or fifth.
Fifth.
Yeah.
Does it matter if I put like a W there? Would that really change anything truly? And it's still, what would that be? W. The fifth. So whatever I put in here, whatever I put in there will be that thing to the
Six.
fifth.
Fifth.
I like that assertiveness, but be careful. So what do I have there in both? 5 halves, 5 halves. So 5 halves, 3 of them, and 5 halves, 2 of them is 5 halves. Do you see how, if I can write this, then does it matter what I put in place of y? No. What this says is if I have 3 of these times 2 of these, I get 5 of these. I don't care what these are.
Okay, so y could be 10.
Yeah, exactly. Y could be 10. 10 cubed times 10 squared is 10 to the fifth. Right? Jeff cubed times Jeff squared is Jeff to the fifth. I love it. Right?
Wait, so like number 75 is x squared, or x squared.
All right, that's a little bit more involved. Let's see.
So it's gonna be like x 25.
Number, which one? 75?
Yeah.
X squared cubed.
To the third.
Where'd it go? 75. There it is. X cubed fifth. All right. Order operations always saves you from yourself. What operations are in there? There's 2 main ones here, right? What are they? Exponents and multiplication. Which one do you do first? Exponents, definitely, right? Pem, so E before M. Not except after C, just always. So what's x squared cubed?
X to 6.
And what's x cubed fifth?
16. So it's x 21.
I love it because you add when you multiply. Let me show you this. I can't remember this whole thing, but a long time ago I was tutoring somebody who was a cheerleader, and she had this whole thing with exponents, and one of them was when you multiply, you add. I don't know if that's going to stick in your brain. When you multiply things with like bases, you add the exponents, right? Well, that will stick in at least one of your brains. When you multiply, you add exponents, right? Yes. I just want something visual to stick in your head. So here, I'm multiplying. You add the exponents. Yeah, there you go. So they're already building on it. All right. So any other specific questions? Yeah.
Number 75 on page 310.
Oh, yeah. This is page 310. And this one says, where'd it go?
That one was crazy.
No, it's not crazy if you break it down to what you definitely have to do first.
Start flipping stuff.
No.
No.
You can change.
And I'll show you
Oh, you can
why.
start canceling stuff. No, you can.
Not quite, no. What do you do first? Exponents or division. So you better raise things to these powers, right? Do you guys see that? Whereas when I had the early problem, I had stuff in here with a negative on the outside. Don't have to do the inside first. Now look here. Now what's the difference? The division symbol's outside of everything. So I have to do exponents before I can divide. I can't move these down because I can't break it out of here, can I? I can't make it not raised to negative 2 power. I've got to do that power first, right? So what happens when I raise things in here to negative 2 power? What do I do each time? What do I do? X to the negative 1 to the negative 2. What do I do with those?
Turn to a positive.
Yeah, because you're going to do what operation?
Multiply.
Multiply, right? When you have a power raised to another power, you multiply the powers. Negative 1 times negative 2? 2. 2 times negative 2?
4.
Negative 4. And what's here?
Squared.
Understood 1 there, right? But we don't even need that because what's z to the negative 2? Well, it's z to the negative 2. Von's even better because all that happens down there is I just change the signs. Everything's times negative 1. So negative 3 times negative 1 is 3. 3 negative 1, negative 3. And z to the negative 1. And now you can look at it like what we're doing. Now you can do the division. You can move stuff around because you've done the exponents first like what our operation says you must do. So let's go real quick. Order operations, parentheses. Anything I can do inside either of the parentheses? No. There's nothing I can really do. I don't want to make fractions inside of fractions, so let me not do that. Next thing is exponent. Okay, I can do the exponents. Now the next thing is division. I can start moving stuff around. What wants to move here on the top? Good. Those 4 y's want to go down? The z's want to go down? What about on the bottom? Yeah, those want to go up, and these want to go up. So the x's stay where they are. Those 3 y's come up. Those 3 y's came up. Those 4 go down. Exactly. Why are the other ones flipping? Because they're to a negative power. So they can only flip or move when it's to a negative power. And so the last thing there is those 2 z's go down, and that 1 z goes up. So now I can do this. I like it. So how many x's are left after I cancel it?
Negative 1.
There's 1 left where?
The bottom.
On the bottom. You guys with me? And again, if you rather, what's 2 minus 3? Negative 1. And that would flip it down, so I'd get it down here anyway. I like the more direct route, right? You don't have to do it the way I do it, but that's just the way I like it. How many y's are left?
1.
Where?
Bottom.
On the bottom. How many z's are left? 1 on the bottom. So what's left on the top?
1.
1. Because everything else canceled out. Not 0. 1.
So now, for instance, like we're taking all that, but now we have to put in a formula. Like number 85, it has like a rectangle and says find the area.
Oh, 85 back in.
To 302, 5.1.
Oh, okay. Oh, okay. Everybody cool with this here before I do another one? And then I got to come to you. Yeah.
Yeah, on page 309, number 18.
We'll do that one in a second.
Number 18, A. That kind of threw me off.
Number, don't worry, man. We'll do yours twice. 3 where?
309.
309.
18A.
18A.
That just kind of threw me
Oh,
off.
yeah. This is a evil little problem.
Yeah, it is.
It's not too bad if you think about it. I mean, what's a negative power mean? What are you flipping, though? No. What's being raised to a negative power? Yeah, this page 309, number 18. Right, this one? I won't do that. That looks freaky. What's being raised to, and this is not that huge of a deal. It should work out either way you do this. But, let me see if you guys get this. It's not a big deal, but isn't 2 being raised to a negative power? So the 2 should flip down. What's left up here then? Negative 1. There's a negative 1 up there still, right? That negative is not being raised to a negative power. Why would it flip down? It has no reason to flip down. And what's 2 to the 4th?
Wait,
2
where
times.
did you get -1?
What's let me see. It always gets a little weird when you have numbers here, but what's definitely understood to be in front of that? What's right there? A 1. So what's even right there? A 1. There's an understood 1 right there.
Okay.
And in fact, let me ask you
Why
this.
is it negative?
Because it's negative.
The negative
If I had like 3 to the negative 2nd power, what happens there? Where do those 3's go?
3 to the bottom, and then there's a 1.
And there's a 1 up there. Why is it positive?
Oh,
Because it's positive. All right? So if I take those 4 2's down, there's a 1 left up, but it's negative. Why? Because it's negative. I mean, I can't answer it any better.
It is what it is.
I like it. And what's 2 to the 4th power? 16. Cool. Now the difference is, if I do this, I think this probably got to be part B. Yeah. Part B says this. Now that is different. What happens there? What's being raised to a negative power now?
Everything in parentheses.
Everything. So you flip the whole thing. The negative 2 goes down. And what's left up here? 1. And what's negative 2 to the 4th power? Positive 16, right? Negative times negative times negative times negative is positive. Right? All the negatives cancel.
So even though you bring it down, it still stays -2.
What are you bringing down? What's being raised to a negative power? This whole thing. What's the difference between this problem and this problem? The parentheses help the exponent out, right? Exponents are weak as hell. They can only reach the thing right there. Parentheses come in and help them out. See, that negative didn't give a crap about that negative 4 power, did it? That negative sign is like, I don't care about you. You took the 2 down, I'm staying up here because you can't touch me. Here, shit, the whole thing's being raised to negative power. The whole thing's got to flip, right?
This might be a complicated question, but if that wasn't 4, if it was 5,
It would still be negative.
it would be negative, then we try to switch it again.
No. Negative numbers don't flip. Negative powers make things
No,
flip.
but I mean, like, say, because it equals 16 evenly. But what if it was, like, a different number and then negative?
So here, let's do that.
I don't get
What's up?
why the 1 is positive on that one.
Because what's understood to be out here?
Oh, okay.
1.
Alright.
You took the whole thing down.
Down.
So you're left with a positive 1.
Yep.
Cool.
Makes sense.
But do you get what I asked?
Yes, I think you're saying something like this. Right? Okay, what happens here? Help me out.
It's the same way.
Same idea. What gets flipped?
1.
Negative 2.
And what's left up top?
1, 1.
The understood 1 that's out there.
And then
What's negative 2 to the 5th power?
Negative 32.
I like it. Negative 32. 5 2's. 2 negatives cancel, 2 negatives cancel, so you're left with a negative, isn't it? If you have 5 negatives, it's going to end up being negative at the end when you multiply, right? Odd number of negatives, and it stays negative. Even number of negatives, all the negatives pair up and cancel, right? So this is going to be 1 over negative 32, because 2 times 2 times 2 times 2 times 2 is 32. And which is better written as what? We normally don't see negatives on the bottom. We just go ahead and bring them up top. Now be careful. Now that's what I wanted to make sure you understood. Have negative numbers ever flipped? Have we ever said negative 8? Oh, that's a negative 8. Let's make that 1/8. Have we ever done that?
No.
Doesn't make any damn sense in the first place. Is negative 8 equal to 1/8? If I owe you $8, do you owe me 1/8 of a dollar? No, of course not. Some of us wish, right? We just changed my negative balance into a fraction that's positive. I like that, right? But that's not the way it works. I want you guys to really pay attention. That's a negative number. It's not a negative power. What are the only things that flip stuff? Negative powers. Negative numbers don't have anything like that. It's just a freaking negative 32 on the bottom. You can't suddenly make itself come up again, right?
Why can't we make 32 come up? Like over here.
What's it being raised to? What's the power that it's being raised to? What's understood to be up there? A positive 1. What's the only thing that makes things flip? Negative powers. I like it.
That's a negative number.
All right? You don't like that at all. I can tell. Math cannot change. We have never, ever, ever had a situation where I had like this 1 over negative 5 become 5. And again, negative 1/5 is negative 0.2. Does that equal 5? No. So what's new now is the exponents have their own properties. It can't change the properties of other things we've been working with already. You can never learn something in math that changes anything you've already learned in math. It might make some stuff easier to do. You might have other ways to do it, but it can't change what we already know is true. We know that that's not true. But if it was this, what's that? That's 5. Because what does a negative power do? It makes it move to the other side, right? That's 5. So a negative number can't do shit. It's just stuck wherever it is. You with me? Yeah. A negative power. What does it mean? Flip it. That's what it means.
The only thing a negative number can do is bring up the symbol and go up, right? Like over there.
Yeah, the negative's got to be somewhere in there.
Yeah.
Right? 1 divided by negative 32 is the same as negative 1 divided by 32, and we just chose not to put a negative on the bottom.
Sounds good.
Cool.
Makes sense.
I like it. So that's the thing, though. I always hear that. That's the number one complaint I get from students is, why does it change? Math is always changing. Never. If you think it did, come see me, because you're looking at it wrong, and it's going to mess you up. Math cannot change. You learn new shit, but it can never go back and fundamentally change the old shit. Right?
Right.
Yeah. How do you mean?
4 and negative 3.
4 to the negative 3?
Yeah. Divided by 5 to the 2.
Squared?
Yeah.
All right, what would happen?
1 over 5.
What wants to move?
The 4.
The 4s, yeah. The 5 is cool where it is, right? The 5s? Yeah. So if I move those 4s down here, what's left up top?
1.
I like it, right? Is that cool? You can never leave 0 behind. There's that understood 1 that's always like lurking there that gets left, right? It only shows up when nobody else is there. So that's basically a definition of lurker. And then on the bottom, can I put those together?
No.
Why not?
Not like
They're not the same base. I like it. So the most you could do is figure out what 4 cubed is and what 5 squared is and multiply them together. Then 4 cubed is what? 4 times 4 is 16 times 4 is 64. And 5 squared, of course, is 25. If it was negative 2, then the 5 would have flipped up. Yeah. Okay. Yeah.
Just why you move the negative 32? You move the negative side.
Well, we know this, right? I mean, if you end up with a negative on the bottom, isn't it convention just to put the negative on the top? Did I actually change the number?
No.
I mean, we very rarely see this written somewhere. It's much more likely to see either this or just a negative in front.
Yeah.
It's just convention. We decided not to leave a negative on the bottom because then it's easier to get lost. Right? That's really why we put it in the front or on the top. These are all the same stupid number. They're all negative 0.125. If you did 1 divided by negative 8, it's the same thing as negative 1 divided by 8, which is the same thing as 1 divided by 8 with a negative sign on it. They're all negative 0.125. How we doing? Okay, maybe. All right, this is the last one, then we'll get to some new stuff here. 80 on 5-2? 5-1. Those are S's, all right?
Okay.
Not the best problem for me with my S's and my 5s, but oh well. Order operations will always save your ass.
I love it.
What must you do first? Exponents, right? Because you can't do anything inside either one of these. You can't multiply yet because exponents are there. They come before multiplication. So how do I do these exponents then?
So we negative t to the 4th.
You gotta be careful. 4 negatives will do what?
Will be positive.
Will become positive, right? So that's the one part of this that I know would be really easy to make a mistake on. Negative times negative times negative times negative is positive.
Once you do it, it would still be negative.
We're doing it now.
Still.
Negative 1 to the 4th power is positive 1, right? Or even better, what's negative t to the 4th power? Negative t times negative t. Isn't that positive t to the 4th? Okay. What happens here? Now, does this negative go away here?
Negative p to 9.
Yeah, why does it stay there? Because there's 3 of them. 3 negatives, 2 will cancel, but 1's left. Right? I always try not to flick you guys off when I do this, but yeah. Right. So this negative is still there, is that cool? Negative 1 cubed is still negative 1. T to the 9. S to the, careful, 15.
15.
Just tested me, right? That's the other really easy thing to do here. You're not cubing 3. And you're not cubing 5. You're cubing s to the 5th. 3 s5s is 15 s's total, right? When you raise something with a power to a power, you multiply the powers. And now what am I allowed to do? We did the exponents, now I'm allowed to do the... Oop. No addition up here, right? I'm allowed to multiply. Now I know what you mean. When I multiply things with powers, I can add the powers. Cool. But there's no addition up here. But t4 times negative t9 is negative t to the 13. Is that to a negative? Is that a negative power? No. How are we doing so far?
Good.
How many s's do I have? S24, S15, so I have S39. Cool. Okay, so there's a freebie. What I'm really trying to get you guys to avoid is to write this thing 4 times and write this thing 3 times. That is one way to do this problem, but then when this is a 10th power, do you really honestly want to write that stupid thing 10 times? No, I'm trying to show you how you don't have to do that. So just to kind of summarize one little piece of this that seemed to give some of us some fits. Negative, what was that? Negative x to the 11th power. What will that be?
Negative 11. Negative x.
Yeah, why is the negative still there?
Because it's odd.
This is an odd number of things.
So odd, yeah, right.
So negative x to the 100th power will be x to the 100th power, because 100 negatives cancel. And then you have 100 x's, there they are.
It's odd, it stays negative. It's even.
Yeah, odd, there's always an odd guy out then. There's always one negative that doesn't get paired. Aww, so he's still there. Even, they all pair up, and they kill each other. Romeo and Juliet.
Yeah.
No. What is the power on this? What's the power? A 1. And then what that's power is 100. 1 times 100 is 100. Right? I don't have any negative powers in here, do I? So that's a key issue right there. There's negative numbers, and then there's negative powers. They do different things because they're not the same thing. Okay. Always doing this now. All right.
Can I ask one more question, but you don't write it down?
Okay.
Just say yes or no.
Okay.
You have like 4x cubed times 3x squared. You don't multiply 4 times 3.
All right. Well, that's actually, I'm going to write that down. Like this. That's a good question here. What is that? What's the only operation up there, really? There are sort of exponents, but they're not doing anything. The only operation is multiplication. And I can multiply in whatever order I want to, right? So, of course, what order will I multiply? I'm not saying do this, but I'm going to multiply in this order. 4 times 3, and x cubed, x squared.
5.
So I'm allowed to do that. Why? Who remembers the property I'm using? Where I can move stuff around? Commutativity. Do you have to know that? No. And so you get 12x5. Do I have to do this middle step? No, dear God. 4 times 3 is 12. X cubed times x squared is x to the fifth. You need like terms when you add or subtract. So what's this here? All right, good. So 3 times 2 times negative 4 is negative 24. 4. 1 more is 5. 2 more is 7. Right? And y to the 7 and 8 is 15, and 2 more is 17. I love it. Do you guys see how that works? When you multiply like bases, you add their powers. When you multiply numbers, you multiply the numbers. Right? So that's how you attack those. You can kind of do them numbers and then alphabetically. Right? Just attack the numbers first, and then attack the x's and the y's and the a's and the m's and whatever else is up there. Right? Attack them one at a time. And if you're able to break a problem down like that, you're somebody who's going to go far in math. If you can do that with a problem, break it into its smaller, easy parts. Don't look at the whole thing at once. Just look at it as the first thing I got to do is 3 times 2 times negative. That's awesome. I can do that. Shit. And then I just count the x's, count the y's, and I'm done. Okay. So, the last thing we did, and I don't think we actually even finished that section, to tell you honestly. We skipped 5.3, so we're going to come back to that today. In 5.4, we talked about polynomials and types of polynomials. Remember that? I don't think we made it as far as the idea of degree. Just to remind us, can somebody give me a binomial?
5x squared plus 2y
Stop right there.
binomial.
Binomial. So I want 2 terms, right? So trinomial would be 1 more term, minus something maybe, right? What are terms separated by? Terms are separated by, yeah, separated by negative and plus. Is that an A in there? How do you spell separated? The reason why I don't teach English. All right. So we have monomials, binomials, trinomials, and above that we just say there's a lot of polynomials. Right? What was the big thing about a polynomial? Can somebody tell me something that's not a polynomial?
Not whole numbers.
No, a whole number is a polynomial. 11 is a monomial.
Yeah.
Why? Because any variable in it, which there isn't any, is raised to a whole number power. right? So that was the trick. So can somebody tell me what would be an example of something that's not a
A
polynomial?
negative power.
Exactly. So like x to the negative 7. That's not a polynomial.
What section is this?
Yeah, this is 5.4. Yeah, this is section 5.4. Something like 1 over x squared for the same reason. Because that's really x to the negative 2. One reason we do that is because I want a polynomial to mean I can plug whatever I want to in for x. What can I not put in here for x? What would make this thing freak out? What number can I not divide by? 0. So if I try to put a 0 in here for x, it would freak out. I want a polynomial to mean that I can put whatever the hell I want to in for x. So if somebody says, I'm working with this polynomial, I can use anything I want to in it. I can plug into it whatever I want to. That's what it tells me as a math person. And for later, we don't even know what this means yet. But I couldn't have like x to the 1/3 power. It has to be a whole number power. We will get to the point of figuring out what the hell that means. What's the fractional power mean? Not yet. But that's not a polynomial because it's not a whole number power. Okay. So here's the last little piece of this section, really. The idea of degree. Of a term and of a polynomial. So the whole idea of degree is the degree of a term is the total number of variables I see in that term. I normally speak pretty fast, so when I go slow, that's a note, right? So for example, if I have 4x squared y, now here's where some of you guys are going to not tell me exactly right, but that's okay, I understand why. How many variables would you say are in there? Total. Not 2, 3. I have 2 x's and a y. Don't I have 3 total? Do you guys see that? Is that cool? So that would be a 3rd degree term. Isn't that pretty easy? The degree of a term is just the total number of variables I see in that term.
So if the exponent was 3, it would be.
This is a
4.
3rd degree term because there are 2 x's and 1 y. So 2, 3. I got 3 total variables in there.
So you don't count the 4?
Is 4 a variable? No. There you go. That's why you don't count it. I count the number of variables I see. So how many? What's the degree of this one then? 7a squared b c 4.
7.
Beautiful, right? 2 a's, 4 c's, which is 6 so far, and a b. That's 7. So it's a 7th degree. This always sounds like I'm talking about karate. It's a 7th degree monomial. I don't know what color belt that would be, but I won't. What about this one? Here's one that freaks people out. I had this one up here earlier. This is a polynomial. What degree is it?
11.
Nope.
I mean 0.
I like it.
0.
It's the 0th degree. How many variables do you see there? 0. So it's 0th degree. Yes, we actually say that. It is the 0th degree.
Now I don't get. So that's the degree of the term of degree of a polynomial.
So we're getting up to the point of the degree of a polynomial. Not there yet.
Okay.
Yeah. So far I'm just looking at single terms, right? That's a pretty simple idea. Hopefully you guys agree with me. Okay. So let's look at a polynomial. So let's first break it down by term, and then I want to define what the degree of polynomial is by that. How many terms are there up here?
5. Oh,
No.
3 terms.
There's 1, 2, 3 terms, right? Because what are terms separated by? Pluses and minuses.
Yeah.
So there are 3 terms. So what would you call this kind of polynomial? It is a trinomial, right? Okay, cool. Oh. What's the degree of this first term?
2.
I love it. It's the second degree, right? Second degree. What's the degree of this guy? Second degree. And what's the degree of this last dude? First degree. I like it. The degree of the polynomial, the degree of the whole thing, is the highest degree I see, including times. How many variables do I see? That's a y. Yeah, it's not a 4. Is that cool? It's a y. So I see one variable here, don't I? One y. So it's a first degree.
So the trinomial.
What's the highest degree term I see in here?
2.
It's a tie for second. So this whole polynomial then is called degree 2. This is a second degree trinomial, to be completely technical. The highest degree that I see. And very quickly, I do want you to understand a little bit about why that exists. Math people didn't just make this up for more definitions to heap on top of students. It's so I know how quickly it kind of grows. If I square numbers, does that grow a lot quicker than just y equals x? Like y equals x. If x is 2, y is 2. Well, y equals x squared. If x is 2, y is 4. It grows quicker, doesn't it? So a 7th degree polynomial would grow pretty damn quick. 2 to the 7th power is huge. So if I just tell somebody I'm an 8th degree trinomial, I'm like, oh shit, that thing grows pretty quickly. Just by them saying those few words, I kind of know what it looks like, which we're not into yet. I know how quickly it grows, all this stuff. Just by those few words. So that's why we invented this idea. What about this one? Try to figure out the degree of this polynomial.
He said that one is.
Yeah. So what's the?
So this is a second degree trinomial. Why was it second degree? Because the highest degree term I saw was second. There's a tie for first place there, right? There's a second degree, first degree, so it's a second degree trinomial. What about this guy here? Just trying to be y. Let me not use y's. I like it. What degree is this first term? Just to catch up to you guys. Yeah, 2 x's, a w and an a, so that's 4th degree. This guy is 6 because there's 3 and 2 is 5 and 1x is 6th degree. So the highest one is 6. So this is a 6th degree binomial because there's only 1, 2 terms. You see that? Cool. Again, it does sort of sound like karate levels. That's kind of fun. Okay. What would this be? 0th degree monomial. Single term there, right? That is a 0th degree monomial. Okay, cool. Now, beyond the definitions, this section 5.4 is going to be awesome for you guys. And I know this, period. Because if you're not able to combine like terms, you should not be in here. Period. Because the rest of this section after the definitions is just combining freaking like terms. Right? That's all it is. So let's do a couple of those, and then we'll go do section 5.3.
So the rest of the class is combining.
No, the rest of this section. Don't get too excited. After I talk about this here. Yeah. I want to finish 5.4 before I go back to 5.3.
Are we supposed to be doing the degree?
No, don't worry about it. It'd be separate problems. They'll say, identify this and tell me the degree, and then they'll say, okay, combine these polynomials, and that'll be like terms.
So if we don't have to do any work on those, do we? If it was just like.
Not really. You don't really, because it should be pretty simple. The one thing to be careful about with this problem is what? What makes this problem a little bit harder?
Is it the same directions for this one?
No, this is just simplify.
Oh.
Right? Exactly. That minus in the middle throws people off.
That's what I was thinking too.
You got to do what with this minus?
You gotta distribute.
It's got to distribute. So one good first step would be to rewrite this with all these minus this is minus. Negative negative is plus. Negative times positive is. And now you can attack it directly. And this should be like oh, thank God for this section. Right? If it is not, that is a red flag for me. So what kind of like terms do I have? Any like terms with this guy?
They have the 2x.
Yeah. There's another one that has x squared and y, right? So I got 4x squared y minus 2x squared y is 2x squared y. Anybody for this guy? Yeah, the other x squared piece goes with that, right? And you guys see, I like this kind of underline it with different shapes. It makes it easier so you don't have to actually rewrite the whole thing and move it around. Minus 3x squared plus 6x squared is positive 3x squared. Who goes with him? Probably the one on the left. Yeah, the other y piece, right? So 2 minus 4 minus 2y. Now, Jeff, if I wanted to, I could say, look at your answer. What type of polynomial is it? What degree?
So, trinomial.
Beautiful. Third degree is the highest degree term I see. Third degree, and there's 3 terms, so third degree trinomial. One.